For me, this image really epitomizes the reason why, if we want to be able to study the oceans and monitor their health, we have to use observations from space. Everything you can see in this image is ocean. This is the North Pacific as seen from the International Space Station. And so clearly, if we want to be able to study these vast areas, then we have to make use of observations such as from satellites from space. And so my name is Jamie Shutler, and I'm from the University of Exeter, and I'm going to be talking about some of the recent advances we made in using satellite Earth observation for studying the marine carbonate system and ocean acidification. And this is work that I've done with all the colleagues that are listed at the bottom left, and our institutes are listed on the right. And much of this work has been funded by the European Space Agency. So we first identified this potential for using satellite observations for studying the marine carbonate system back in 2015. And this was around the time that the first satellite-based observations of salinity were becoming available. And we knew that there was a strong link between salinity and the marine carbonate system. And so when you combine that with the already established ability to monitor and study water temperature from space, it meant you could then actually start to describe and understand and study the marine carbonate system. Then more recently, we also did a large review with the International Working Group, where we not only identified some of the opportunities, which I'm going to talk about, and we have now explored some of the initial results from those I'm going to talk about in a second, but we also identified a number of other other advancements which would be possible. So this work is very much at the beginning. There are many more advancements that we could still make. And around the time of the first publication, when we identified the opportunity of using satellite salinity observations, we received quite a lot of press coverage, and here's an example. Headline: Ocean acidification now watchable in real time. So while the kind of essence of that is correct, we can observe the carbonate system from space using satellites. We can't do it in real time. So the detail of that headline isn't quite right. So the first work we did was we looked at particular regions around the globe, and we wanted to identify not only how precise and how accurate satellite observation methods could be, but also we wanted to look for the optimal approaches. So we assessed not only satellite salinity observations, but we also looked at lots of other sources of salinity data as well, and then assessed them all. Now this work means that you can then start to reconstruct the carbonate system. So you can see we can estimate alkalinity and dissolved inorganic carbon here. You can see it on the top two animations, and at the bottom we've got the original salinity data. And this is the North Atlantic, and you can see the plume of the Amazon coming out from the land and then flowing into the ocean. So this is work that we published, and we studied not only the Amazon area, but we also looked at the Greater Caribbean, the Bay of Bengal, and also globally. But what was particularly exciting about this piece of work was it enabled us to actually study the whole carbonate system. So once we have two of the carbonate system parameters, we can then combine that with our salinity data, our water temperature data, and pressure, because we know we're looking at surface waters. And that enables us to then calculate the whole carbonate system, which means for the first time, for example, you can have synoptic scale observational based data of North Atlantic pH. So you can see that on the right, and you can see the low pH waters of the Amazon flowing out into the Atlantic. So that was really the basis of where the OceanSODA project started from. So OceanSODA stands for Satellite Datasets for Ocean Acidification. And within this project, we expanded our focus quite a lot. We looked in the global case, but we also had a number of different regions we focused on, which predominantly were upwelling regions and also river-influenced regions. And then in addition to that, we also have a focus in Arctic waters. So each of these coloured blocks represents a different component of the work within the OceanSODA project, and each of them has both a scientific component and also a downstream or an impact focused piece of work. So the scientific component is about the algorithm development or the technological advancement that provides and enables us to produce a set of data. whether that be global or and time series, or regional and time series. And then we have the impact or downstream analysis, which is the point where we actually exploit and use those data for some sort of real world application. And all of this work was guided by representatives from WWF and also from NOAA to ensure that what we're doing is relevant to both the scientific community but also the potential user communities. So the first area we looked at was extreme acidification and compound events. This meant that we had to develop the capability for producing long time series, global observation-based data sets of the carbonate system. And then these have since been used, as Nikki, who's going to be talking in a few minutes, will explain how they're being used to study compound events. So this is an example global map of pH. You can see the red dot, the location just off the west coast of North America. And this approach, these data that we are now able to produce, allows us to be able to study the pH through time for a particular location, and therefore be able to identify when that particular location is experiencing extreme conditions. Another area we've looked at is large river outflows. So this is particularly focused on the Amazon and on the Congo. First of all, we wanted to identify the optimal approaches for studying those riverine regions, riverine influenced regions. And then it allowed us to actually be able to study how carbon and quantify how much carbon is flowing from the land into the ocean from those rivers, but also how those rivers are affecting and influencing the carbonate system in tropical reef environments. So at the bottom here you can see a picture of the Amazon plume, and then labelled we have our different areas, marine protected areas and coral reefs. And using the time series data, we're then able to identify which reefs are being influenced strongly by the river and therefore experiencing very highly variable carbonate system conditions. And from that, that helps us understand how they may change or how they may react to long-term changes in the marine carbonate system versus coral reefs, the ones in red, which are experiencing very stable and very low variability carbonate system conditions. So this kind of information can help guide and support conservation efforts. We've also looked at upwelling systems. This is using wind speed data. So here, if we know the wind conditions along coastlines, we can actually use that information to understand how much water is being drawn up from below, how much water is being upwelled, and then how much water is actually being transported offshore. And we have been able to verify that our upwelling flows, both vertically and horizontally, are consistent with the observed changes in the pH within these regions. And so this kind of information has clear use within fisheries and understanding how fish stocks are likely to be impacted in the future as our climate continues to change. We have also included some work on the Arctic, and so we had a PhD student who's associated with the project, Hannah, who will be also be talking in a few minutes, and she focused on Arctic waters. Now, the first part of her PhD was about identifying economically important fish stocks which live in these Arctic waters, and also we wanted to understand how much we knew about how ocean acidification is currently affecting their different life stages. And it turns out we know very little. And so it's quite clear from her work that satellite observations are needed to understand the variability and the baseline conditions that these animals are currently existing before, and that would allow us to then understand how they're likely to be impacted in the future by future changes in the marine carbonate system. And so that's work that Hannah will be talking about in a few minutes. Towards the end of the project, we actually had a stakeholder workshop. And the idea here was to try and increase the connective elements between our new advancements and how they could be used by actual user groups and stakeholders. This was a completely online workshop. We had more than 50 international participants from all over the world. So we held it in 2 half-day slots to allow people from different time zones to all connect. And we had keynote talks from the International Union for Conservation of Nature, from Ocean Conservancy, the Ocean Acidification Alliance, and also the Goa Observing Network. And it was quite clear from the workshop that we can actually group stakeholders and users into 3 different groups that have fundamentally different uses for the data, kind of data we can provide. So we can have policymakers and elected officials, resource managers, end users. So the policymakers, they're really interested in understanding the variability on very broad scales around their regions. And those kind of data could then help them understand drivers of change, and they can also be used for highlighting the issue. So, for example, US or North American states policymakers can use this kind of the information we provide from satellites to help highlight the potential threat to their region if they want to highlight to the higher levels of government. Resource managers, so this is more regional or state level. They can use these kind of observation data that we can provide for identifying susceptible regions for helping to target management. Whereas more sort of the lower sort of smaller organizations or near coast companies, such as shellfish farms, for example, they already have a very high level of knowledge of the marine carbonate system, but they wouldn't necessarily have the similar experience in using Earth observation data and interpretation of those data. So therefore, clearly, if they were to want to use the kind of data we can provide, then we have to provide some sort of training. And clearly, these groups also have a very near-shore interest, whereas much of the work we've done so far, I would say most of the work we've done so far is very much offshore. And so at the moment, these are very much where the work is progressing. We are now beginning to engage with some of these groups, and with the help of the Ocean Acidification Alliance, we're now working or have begun working with a group of resource managers in the east coast of North America, so the Pacific Coast Collaborative, to try and ensure that what we're producing from our research, the data sets that we're producing, are usable for their needs. I just wanted to end on some of the possible future advancements. I said at the beginning that we're very much at the beginning of this work. With the advancements we've made recently, such as those I've just described in this talk, we have the potential for moving down to about 25 kilometer spatial resolution and an 8-day observational based data set. So currently the work I've presented is all monthly and 1 degree, so it's about 110 kilometers resolution. But we can see that with these current approaches, we could go down to about 25 kilometers in 8 days. However, in the near future, one particular advancement is the Copernicus Imaging Microwave Radiometer, which is a proposed satellite mission. The first one's supposed to be launched in 2025, and there'll be 3 of these in orbit, so it's about operational use. They're actually being developed initially to focus on the Arctic. But they hold the capability of actually providing 25 kilometer spatial resolution data or less, but on a daily basis. So really, in the near future, the opportunities and the potential of these Earth observation data sets and the potential uses for them is really going to grow quite considerably. So I'd just like to end on, these are all the references that I have referred to within this talk, and so you can pause the video if you want and actually look at those in detail. And thank you very much for listening.